In this lecture, we will try to make you understand how digital logic levels depends on various types of circuits. That means, we have a general idea that digital logic or digital signal, it is only about zeros and ones. First of all, that is a very misconception. We have already discussed that many a times. Digital signals can have many number of levels. If it is a binary signal, then only it is about two levels. One is low level, another is high level. Low level is called 0, high level is called 1. And there may be n number of levels depending on the type of digital signal we are using. If you are using octal level, you have got 8 number of levels. It may start from 0 to 7, it may start from 1, end at 8. So, it can happen. And there are many types of digital signals where even you do not use these numbers 0, 1, 2, 3, like there is ASCII code where you do not use these numbers at all. There are symbols used for different voltage or current levels. So, let me take this topic that logic levels depends on the types of circuit. What does that mean? Suppose we say that we are using binary signals only. That means we are using 0 and 1 only. Now, what is that 0? What is that 1? We have already discussed that 0 means it is a low level signal and 1 means high level signal. And the threshold is defined as, or it is defined by the user. Suppose we have a signal like this. This is a discrete time, discrete value signal. Suppose this is 0th instant, 1, 2, at 3rd instant there is a value, at 4th there is a value, maybe at 6th there is a value, 7th, 8th, 9th, 10th. Then onwards, every point of time there is a value. And these values are, say this is 5.5, this is 4.3, this is 3.7, this is 3 exactly, maybe this is 2.7, then 3.9 and this is say 2.8. So, this particular type of signal, if we want to make it binary, first of all what we have to do? Already I have told you that we have to put a threshold level. Now, let us take that the threshold level is at 3.2 volts, somewhere just above 3.2 volts. So, by my logic definition, we have told that logic 0 will be anything less than 3.2 volts, considering this is a voltage signal, this is time axis. Anything greater than or equal to 3.2 volts will be taken as logic 1. Now, this definition in the previous lecture also I have told you that this threshold selection tells you what values will be logic 1 and which values are logic 0. Now, how do you select this voltage level? How do you actually, where do you put the threshold level? That is very important, and that is why digital logic levels depends on the type of logic circuit you are using. I will briefly give you 2-3 very practical examples, like there is a circuit called MOS circuit or CMOS rather. CMOS stands for complementary metal oxide semiconductor. In fact, the full form of this is CMOSFET. CMOS stands for complementary metal oxide semiconductor, FET stands for field effect transistor. Now, if a circuit is made of CMOSFETs, complex electronic circuits, they are made of many discrete devices. If the circuit is made of CMOSFET, the logic level is set like this. Anything greater than or equal to 4 volt is taken as logic 1 and anything less than 1 volt is taken as logic 0, and in between this it is called high Z state or high impedance state. Now I am giving you a practical example or practical electronic circuits example. When you work with a practical electronic circuit, there will be n number of small chips where there are lakhs of discrete transistors. Like you consider a Pentium 4 processor. In that Pentium 4 processor, there will be more than 10 lakhs transistors inbuilt. Now, out of those 10 lakh transistors, majorly either they are made of a MOS logic, or you are using a MOSFET, or you are using a BJT, that is a bipolar junction transistor, that is a separate class of transistor. Considering you are using MOSFETs, then your logic 1 will be set as anything greater than 4 volt will be taken as logic 1, anything less than 1 volt will be taken as logic 0. Now you understand, suppose there is some problem has occurred in your system and you want to rectify that error. If you go on checking that why this circuit is not working, then you must understand why the circuit is not working. That means you must have this knowledge that if at the input, if you do not have more than 4 volts, then the circuit is not recognizing it as logic 1. So the circuit will not work. If it is not less than 1 volt, then it will not consider that as logic 0 or low level voltage. So you have to check whether at the input the voltage is between 1 volt and 4 volt. If it is between 1 volt and 4 volt, the circuit will offer a very high resistance. As I have told that in between it is called high Z state, it offers very high resistance. That means for this particular type of circuit, the definition of logic 1 and logic 0 completely changes. I have taken in this example, in my case, I have taken it as 3.2 volt. That is why above that, I have taken as logic 1, below that logic 0. This is my definition. I have designed my circuit accordingly. Now, in a practical example, I have shown you that if you are using a MOSFET driven circuit, there this logic 1 is greater than equal to 4 volts and the logic 0 is less than 1 volt, and in between the state is high Z state. So you must have this knowledge, and that is all about digital logics or digital circuits or digital signals, that according to the type of circuit, the definition of logic 1, definition of logic 0 changes. So it is not only, first of all, it is not at all about zeros and ones, it can have many other levels. Secondly, if you are considering digital binary signal also, then also that definition of 0 and definition of 1 changes according to the type of circuit. I have given you an example of MOSFET. Next, another example I am giving you, that is of TTL, transistor logic. Transistor logic, that means bipolar junction transistors, BJTs or bipolar junction transistors are used in that type of a circuit, and this particular logic circuits are called TTL ICs. Like CMOS FET driven ICs are called CMOS ICs. Then this BJT driven ICs are called TTL ICs. Now, if you are using, suppose Pentium 4, I gave you an example with MOSFETs, CMOSFETs, because they use MOSFETs. Now, I will give you one practical example, very simple gate, NAND gate. NAND gate, these were actually developed maybe 20-25 years back, and in those days TTL were used, TTL logic was used. Now also they are manufactured by TTL logic only, or the main component of the circuit is BJT or bipolar junction transistor. Now in this case, the most important or interesting point is, in this case logic 1 is anything which is greater than or equal to 2.4 volts. This is again one very practical example, and logic 0 is less than 0.8 volts. So now you imagine, you just compare with MOSFET. Suppose anything which is, you consider one particular voltage which is 0.9. 0.9 volt for MOSFET, if you remember, I told you for MOSFET it is less than 1 volt is logic 0. So 0.9 volt for if you are using a MOS circuit, it will take as logic 0. But if you are using a TTL logic which is using BJTs, it will not take it as logic 0, because by that definition point less than 0.8 only is logic 0. So 0.9 for that type of circuit will be treated as a high Z state voltage. It will not work. So that is why it is so very important to understand. Here it is anything above 2.4 volt is logic 1. So you can understand that the logic 1, logic 0 definition completely depends on the type of circuit you are using. I have shown you two very practical examples using BJT and using MOSFET, that how for different voltages the logic levels will change and accordingly the circuit operations will change. If you do not know that it is using what type of logic level, then you will not be able to comprehend that work and operation of the circuit at all and rectify if there is any fault at all. So in the next lecture we will discuss the more about types of digital signals and other types of digital circuits.